Hello and welcome to this Python tutorial. Alright, so this is going to be a very exciting tutorial because in this tutorial we are going to see if we can achieve our goal to get an accuracy of more than 80% on the test set. So did you figure out a way to reach that accuracy without doing any parameter tuning? Well, at the end of the previous tutorial I gave you a hint. The hint was the answer is in the title of the course, deep learning, and indeed the solution that will make us achieve our goal is to make a deeper deep learning model, that is a deeper convolutional neural network. And how can we make it deeper? Well, we have two options. First option is to add another convolutional layer, and the second option is to add another fully connected layer. So maybe you experimented and maybe you figured out that the best solution is actually to add a convolutional layer. So that's what we'll do in this tutorial, but you can always improve your model by considering the two options, that is adding a convolutional layer as well as a fully connected layer. But I bet that we managed to reach our goal of getting a test set accuracy of more than 80% by only adding a second convolutional layer. You'll see how it will definitely improve our performance results on new observations, that is on the test set, as well as reducing the overfitting. So let's do it and let's see if I'm right. Besides, it's important to do this tutorial because you're going to see how it is so easy to add another convolutional layer. Because basically what I only have to do is take this line, copy it, and then paste it right after the first two steps. That is right after we built a convolutional layer on which we applied max pooling to get our pooling layer. So that is exactly right here, and that is of course before the flattening step. So I'm going to paste this line here that adds another convolutional layer, and of course we also need to apply max pooling on this convolutional layer that we just added, and so I'm going to paste that here. And let's specify here that we're adding a second convolutional layer. Alright, and now in these two lines here we just need to change one thing. It's the input shape parameter, because we had to specify this input shape parameter because this corresponds to our image and how our CNN should expect, that is which dimensions it should expect as input of the CNN. And so that's why we specify this input shape parameter to specify the dimensions of the preprocessed images that are going to be the input of the CNN. But here we are adding a second convolutional layer, and the input is going to be not the images, but the pooled feature maps coming from the previous two steps. So we're going to apply the convolution trick and the max pooling trick not on the images, but on the pooled feature maps. So that's exactly the same operation, the same trick, but it's on the pooled feature maps from the two previous steps. And so we don't need to include this parameter input shape here because we only need to include that when we don't have anything previously. Here we needed to include that because we didn't have the images previously yet. But here we have something before. It's the pooled feature maps of the two previous steps. So Keras will know this, and therefore we don't need to include this input shape parameter. So in conclusion, when you're adding a new convolutional layer, well, you just need a number of feature detectors, the dimensions of these feature detectors, and an activation function. And then you apply max pooling with only this pool size parameter. And so here we're going to keep the same parameters. You'll see that we'll get good results. And then if you want to have fun adding new convolutional layers, then you can increase the number of feature detectors and double it each time. So for example, you can add a third convolutional layer with 64 feature detectors. That's a common practice, and that leads to great results. But I bet that now with only these two convolutional layers, we'll get to a test set accuracy of more than 80%. So let's check it out. As you can notice, I restarted my spider. So what I'm going to do now is basically select everything, and I will just need to press enter, and this will run the whole code. So before I run it, let's remember, in the previous tutorial we only had one convolutional layer and we got an accuracy of 75% on the test set and a difference of 10% between the accuracy of the test set and the accuracy of the training set, because the accuracy of the training set was about 85%. And now we have one goal with this new CNN with two convolutional layers. It is to get a test set accuracy of more than 80% and a much smaller difference between the accuracy of the test set and the one of the training set. So let's see, let's run this, and let's get some little coffee. So ready? 3, 2, 1, go! Using TensorFlow backend, found 8,000 images belonging to two classes for the training set, 2,000 images belonging to 2 classes for the test set. And here we go with the first epoch, 1 out of 25, and we are beginning with an accuracy of 50% for the training set. And the loss function around 70. And remember, this is going to decrease and this is going to increase. And not only we want this accuracy to go over 80%, but we also want the accuracy of the test set to go over 80%. So right now it's running. I'm very excited to see what happens in the end. And before we get some little coffee or get some lunch, let's see the accuracy of the test set for the first epoch. Here we go, almost there. And here we go, first epoch done. The accuracy obtained on the test set began at 55%, almost 56%. So yes, that's actually like before. We're starting slowly, we're starting low, but let's see what we'll get in the end. So right now we're in the second epoch. The accuracy of the training set is already increasing pretty well. We already reached 60%. As you can see, the ETA is quite the same as before, so it's not because we added a second convolutional layer that we need to wait more, so it should be okay. The second epoch is almost done, and the accuracy is well increasing, 64%. Let's see what we'll get at the end of the second epoch. And we got, indeed, 64% and 68% on the test set. Alright, so let's let this run. Let's get some coffee or let's take a little nap. As far as I'm concerned, I just woke up, so I won't take a nap. I'll just be happy with a good coffee. And let's keep in touch in 20 minutes. Alright, we're almost done. Let's see what we get. That's the last epoch, 25 out of 25. ETA 5 seconds. We are about to get an accuracy of 85% for the training set and 82% for the test set. Wonderful! Not only we reached our goal to obtain a test set accuracy over 80%, and also we reduced the difference between the training set accuracy and the test set accuracy, because now indeed we get a difference of 3% as opposed to this 10% difference that we got in the previous tutorial. So congratulations! We made a great convolutional neural network model with a good prediction. So you can still play around and try to improve this model. Of course, adding more convolutional layers will help get an even better accuracy. But if you want to really get a better accuracy, well, that would be to choose a higher target size here for your images of the training set and the test set, so that you get more informations of your pixel patterns. Because indeed, if you increase the size of your images, that is, the size down to which all your images will be resized, well, you will get a lot more pixels in the rows and a lot more pixels in the columns in your input images, and therefore you will have more informations to take on the pixels. So you can try this, but I would recommend using a GPU or trying this before getting to sleep, and you might even be able to get an accuracy over 90%. Alright, so that's the end of this section. Congratulations for having made a convolutional neural network. We did not make a cake, and I hope this can be useful for you in the future. Until then, enjoy deep learning!